Troubleshooting. We'll take a look at an actual pump station now and just kind of a little bit of troubleshooting some of the components on that. On this one, we've got an amnion filter. We'll look at the scanner motor. That's what I was talking about. Makes the suction scanners in that filter go back and forth. We'll show the inside of one of these so you'll see what I'm talking about if you've never seen an amnion before or had one opened up apart. Pressure differential switch, the solenoid flush control valve here. We got a Symmetrics flow meter right here, and then of course your check valves and valves. This is a high pressure switch. We'll look at those, a high pressure relief valve. We'll look at these a little bit more in detail too. And of course your high pressure switch, transducer, all your other measuring items. So this is pretty typical what you would see on one of our manifolds. Pressure gauge, pressure switch, high pressure switch, and transducer, and the temperature switch. We also have a flow switch. Now, like I was shown before, that Symmetrics flow meter, if it has a flow meter, it's not going to have a flow switch. If it doesn't have a flow meter, it probably is going to have a flow switch. We might use that for a couple reasons, either to sleep by flow or mostly for protection, low flow protection. Occasionally a drive might not go, there might be reasons why a drive might not go into a sleep mode. You don't want to just sit there running and cook the pump with no flow. Temperature switch, about the only time you'd see this is on a centrifugal pump. Here's the volute of a centrifugal pump. We just plug these into there, and that way if there's no flow, it sits there and it heats that water up. We can shut it down before it damages the pump. Again, the field terminal strip, every one of these items, it all comes up into the field terminal strip. We'll look at some of the common faults on these systems and stuff when we continue after lunch. So I think right now what we'll do is we'll go ahead and break for lunch, and then we'll come back and we'll go through some of these components.
That's it. I want to keep going in class.
Anybody have any questions on this?
Oh, really?
Pump station, is everybody, anything you see on here you're not sure what it is, or any questions, or?
What's that big red?
What's that big red thing?
Really big red thing.
Oh, the really big.
Torpedo?
That big red thing, that's a filter. It's an H-bomb.
So you used a clay valve for your pressure relief valve.
No, that was Raphael.
We do use clay valve mostly now. We're using both. Yeah, we used to use these primarily, almost all of them, but we switched to clay valve. There's more engineers that were specifying clay valve, and we got to a pricing point close to these. We just decided to switch to clay valve. They're good valve. Clay valve is.
Okay.
You're more versatile parts in the clay valve, isn't it?
Yeah, they can do just about anything with the valve.
Yeah.
It can get kind of complicated. So we looked at some of these items, so we'll see what might happen if we do get some faults. So again, on the touch screen, we'll display what the fault is. So one of them you might see is a low pressure fault. Low pressure could be due to a bad transducer's bad or malfunctioning. One thing we do on our pump stations and our control panels is we program the drive to use a 4 to 20 milliamp device, and so if it transducer completely goes bad, or the wire gets cut for some reason, it drops below 4 milliamps, then we'll fault. But occasionally I've seen transducers partially get frozen and stuck at a certain value or get wet. So look at the transducer, see if it's bad or malfunctioning. Might be a mainline break or overusage. We do a shutdown, a low pressure shutdown is primarily used for the mainline break, is probably the main reason why we put it in there. If it pumps, at full capacity and it can't get up to pressure and it goes through a certain time delay, then it will fault on low pressure. high pressure faults, same thing, transducer might be bad, or the high pressure switch is malfunctioning, high pressure relief valve's not working correctly. High pressure switches, this is the one that we use the most of. It's got you see the knurls around the outside there, you just twist that to adjust it. Counterclockwise down, it increases the pressure, back up and it decreases the pressure. One thing to keep in mind is we actually have two different ways to shut down on a high pressure switch. We have on a high pressure fault. We have one built into the PLC because it sees the pressure of the transducer, and there's a setting in there where you can tell it at what pressure to shut down on high pressure. So it's monitoring the pressure by the transducer. If it exceeds that pressure that you set in there for high pressure, you'll get a high pressure fault. If for some reason, user error, they don't set that correctly or something's wrong in the PLC, this is kind of a backup. This switch is usually set at a higher pressure than what you would set in the touch screen. So then if it mechanically switches this switch, you'll also get a high pressure switch. High pressure relief valve not working correctly. Here's a clay valve on there. Actually, what we want to do is we want the high pressure relief valve to be the first thing that acts. We want it to be able to open up, relieve the pressure, any surges, and not cause a nuisance high pressure fault. So this is typically set anywhere from 10 to 20 psi above your operating pressure, and then set your high pressure shutdown in your touch screen 5 to 10 psi higher than this, and then adjust your high pressure switch for even higher than that. So hopefully this valve is just going to open and relieve the pressure, not going to cause any nuisance high pressure trips. This is a clay valve. Ones are pretty simple. It's got a pressure regulator that's adjusting here. This is the Dorot and Edifin ones that we used to use. They both are adjusted in the same way. If you take this black cap off, there is an adjusting nut. Here's the black cap on this one. Take that off and you're going to see this exact same setup. Loosen up this locking nut. Again, crank it down clockwise to increase the pressure, counterclockwise to decrease it. So make sure that that's adjusted correctly and it's blowing off, before you're going to hit a pressure where your high pressure is going to shut down.
Would that be like a PRV as well? Where
It is a
has
PRV. A lot of people call it a PRV.
A life on it, on the spring and everything in there. It should have normal maintenance. Replace it every 10 years, 5 years?
Yeah, if that. Depends on the water quality. I've torn a lot of these apart, cleaned the sediment out, and got them going again. These you can get a kit for. You replace a little rubber and diaphragm in there in the spring, and there's really small pin-size hole orifices in there that can get plugged up pretty easy.
I don't know about Doro, but Clay Valve recommends to overhaul their valves every 12 to 18 months.
Really, that often?
Yeah, to clean them up. The life expectancy on like a 6-inch valve or 4-inch valve or smaller is about 18 months on the materials. So if you look at the materials, you'll actually see them wear out. They'll have like a little ring, or even still the actual kit will have little squiggly lines, little nice fresh yellow squiggly lines. About 12 months, I mean, if you were to take it apart a year later, you can actually take it apart and just look at it to clean it. You would see those squiggly lines will actually start wearing out, and that's when they recommend to change it out. It'll actually be pliable. The rubber will still be pliable, but what you're looking for are blisters and maybe cracks. You want to prevent that from happening. So again, that's what I call preventive maintenance.
Yeah.
So again, so like that one there, that diaphragm there is probably, you don't have to ever change that out until it actually blows out.
Like this one here.
Yeah.
Not near
That kit, I mean, it's
When I worked
probably
for the
like say
contractor,
10 years or whatever for that. I mean, sometimes 5 years those things will go out, but the clay valve parts they recommend 12 to 18 months. Like an 8-inch valve or a 10-inch valve, gosh, you could probably go 24 to 36 months on the bigger valves because they move slower.
Yeah.
and they don't have much movement.
And I think that probably has a lot to do with how often it gets used and that. On some of these, this probably never would activate if everything's normal.
If it doesn't use, if it's not being used, it's even, I recommend even stronger to take it apart and clean it and put it back together, even if you don't put a new kit in it once a year.
And I have seen these rubber diaphragms get pretty hard.
Yeah.
And then they won't flex much.
Yeah, I'll do it, turn it on 180 degrees, turn it 180.
Yeah,
Every
you do
time
that
I
on the
take it apart.
filter valve, filter
Yeah.
flush valve too.
Yeah,
Every year you flop it around and
right,
my guys only use these stations anywhere up north 3 solid months in the year, maybe 4.
right.
And then in the normal area down on the coast and stuff, might be as much as 6 months a year. And nobody's changing their diaphragms that often.
Well,
Some guys with 6 inches.
well, if you're
That's never been out in
up
20 years.
over my house, they do the same thing.
Yeah.
Okay, they're down, they shut down for, November
Yeah.
till what, March?
Yeah.
So they're only half a year, so you just figure, okay, well then, double that up in time instead of 18 to, 12 to 18 months, then we'll get 24 to 36 months. You could probably
Pull some of the
go.
big valves apart, it's just mud in the
More
corner.
realistic.
But still, even if your valve is not running, if it's not working, you want to check your ports.
Yeah.
I don't know about your water quality, but out here, I mean, you get buildup around the ports for the pressure ports, especially the smaller ones, the 1/4 inch ones. The bigger one, the 1/2 inch or the 3/4, you got more buildup to, and that will cause a problem with the valve not functioning, not even opening. And well, guys, my valve never opens. Well, guess why? It's closed. It's shut. It'll never open.
And it
So
can depend if it's real silty water and stuff too, where I've seen other places where
Yeah.
it's real scaly and builds up.
yeah, so ultimately, maintenance is always there, whether they think they have to do it or not. Some just set it and forget it and thinking, well, it's running fine, nothing's running, no leaky squeakies, then I'll just leave it alone. Turn it off, come back next year, turn it back on, it works again. Hey, I'll save some money. But it's not true.
Again, here's how you adjust it. We've got 5 to 20 PSI in here. It all depends on the system. It's usually 10 to 15 above your operating pressure. You can test these by, opening and closing your discharge, isolation valve. I like to close the valve and turn it into hand and then operate that speed potentiometer on the door and get it up to the pressure where you want it to open and make sure it's opening. Sometimes you can visually see the discharge, if it's down the wet well, you can open up the hatch and see when the valve opens, closes. Another fault that you might see is low flow. Again, we have that flow switch, or a flow meter could be malfunctioning. If you know that there's flow and you're getting low flow faults, then I would look at the flow switch. Make sure that in the touch screen that the low flow shutdown or low flow fault setting is higher than what the meter is reading, at the lowest demand that there is. Sometimes we'll see some have a demand out, drip lines or something out there, and so the flow meter has a hard time reading those low flows, and PLC might see 0 occasionally, and it might cause nuisance trippings.
What's the purpose of having a low flow fault or alarm?
Mostly to keep the pumps from just sitting there when there's no demand. Typically what happens is you get up to pressure and then you don't have any more demand. The drive, speed of the drive that's spinning the pump slows down, and it'll slow down to a point where it's just spinning fast enough to maintain that pressure. There's no flow, there's nothing going on out in the field, so it's just trying to maintain that pressure. Well, if it reaches that point, it's supposed to go into a sleep mode and go to sleep and monitor the pressure. And then when the pressure drops, then it wakes back up. If you try to do that on a well where the water table changes, then you might be 3 or 4 months down the road. If the water table is a little bit lower, now that drive can't slow down that slow. It has to be just a little bit faster to maintain that exact same pressure with no flow. And if the sleep setting's not set correctly, then it won't go to sleep. So it's just gonna sit there and maintain that set pressure, for example, 65 PSI. It's pumping no water, so now you don't have any water running through the pump, and it can overheat it. You need water running past the motor and on a centrifugal through the pump. So the low flow switch will sense that there's no flow, and then it will go through a time delay, and then it'll say, hey, we haven't had any flow for this long amount of time, and it'll shut it down. So it's mostly to prevent from burning up your pump, overheating the centrifugal, or overheating the submersible motor.
So then, once it's shut down, system pressure bleeds off due to leaks or whatever, does the pump restart again, or does it
It
take
doesn't
away?
on a fault. If it faults on a low flow fault, you have to manually reset it.
Okay.
It'll become a nuisance, and then you'll troubleshoot it and find out that either your water table has dropped, or your intake is plugged up, or
Mhm.
something.
Yeah, it could be because the pump's not performing, like you say, intake plugged up.
But we can make the pump station go to sleep based on a flow set point too. Say, hey, once you
can.
get down below 5 gallons a minute, I want you to go to sleep.
We can. We have, we can also do it by flow meter or the flow switch. We have an option in the PLC where you can change it. We try to do it by VFD, but there is an option in the PLC where you can switch it to sleep by flow.
Mm-hmm.
And now if it's flow meter or the flow switch, either one, whichever the system happens to have, if it says I haven't had any flow for X amount, or whatever you set the delay for, then it will go into sleep mode. At that time, then it will monitor pressure, and the pressure drops, and it will wake back up and start
Okay.
back up and begin pumping again.
I think every single one of the little irrigation booster pumps that you've shipped into my territory have all been go to sleep by flow.
Those typically we do, the smaller ones like that, we do, yeah. So again, pump performance or suction clogged. These are just some of the things that you might look at if this occurs. Low water, system demand is greater than the supply. We see this occasionally. A lot of the canal companies around here, they like to put in the weirs and only allow so much water. Subdivisions, they all like to water 2 or 3 o'clock in the morning, and so if you're overusing what's coming in, you might see a low water fault if the system demand is greater. If you do get a low water fault and the water in the vault is, up to normal level, it could be because that's happening. Now everything's normal when you come back on site and take a look at it, everything's normal. Low water float is faulty. We either use a level sensor in the vault or a float switch. It's just a bulb with a weight on it that floats. Occasionally I see those where the incoming water is causing turbulence, and so it's sat there and rubbed up against a concrete vault for several years and wore right through it. I've also seen some that have been in so many years that the cord gets so stiff that it just won't bend back down. Cracks. So we do usually have a port right on top of the pump station where you can pull that out and pull the float up and check it and make sure you can actually hold that in your hand and hold it up, reset the fault, and make sure it faults when it goes down. That's a good test to do in a startup, but you can test the float switch that way. So that's another reason it might be a low water float switch. Submersible level sensor. Occasionally we'll put a level sensor on a system. It's just like a transducer. It's a 4 to 20 milliamp device. Drops down in the water and it just measures the pressure of the water above it. Typically those would be set in the touch screen. You would set a setting on there of a water depth of when you want it to shut down on low water. So just make sure that setting is correct and that the water is not dropping down below that level.
Is that going to be covered at the setting the depth of that transducer in startup?
Yeah. Most of them, they typically set right on the bottom.
So right
or
there, you
within
already
an
got
inch
it
off the
cut and
bottom.
set, and so all
We
you
do
gotta do
when we
is just
do a
set it.
system, yeah.
Okay. So if we had to put in a new transducer, for example, probably match it to what we pulled out. And
Yeah,
of course,
we-
it would be the same size transducer or whatever.
Right, yeah. If we know what it is, or you pull it out and read it. It could be a 5 PSI or 10 PSI. Some of the smaller ones, we might even have them in inches of water.
Right.
Water columns. Clear water, or CW screen not working correctly, those can get plugged up. Some of the things that might cause that is the spray wands. There's spray wands right here and over here. The water pressure coming into here causes that to spin, and it forces the debris from the spray on the inside forces it out away from the screen. If that's not spinning, that could cause it to not enough supply going through the screen, getting to the vault. That could cause a low water fault. Spray wand bearings are locked up. There are bearings in here. They used to use an older brass type bearing. If you've seen an impact sprinkler with the spring on it and a little nylon thing, it looked exactly like that. And those would get crud on them and wore out pretty quickly. About 6 years ago, they switched to a sealed ball bearing system. They last a whole lot longer now. They do make kits for these. You can order this bearing in a kit. Even if it was the old style, it'll still fit in there. The new ball bearing ones will. So if it's spraying but it's not spinning, you would see clean spot here and debris all over the rest of it. But of course, if it's out in the middle of a pond or something, it's really going to be difficult to look and see if it's actually spinning or the nozzles are plugged. One thing I wanted to mention is if anybody's ever involved in a new install on this and you have the opportunity, make sure that they flush this line. We still see that a lot of times. The contractor will be out there, they'll install this 1.5" poly line in a trench going out from the screen out to the pump station, and the guy's dragging it through the trench and everything, and anything that's inside of that poly pipe, as soon as we go out to start the pump station up, and the water just pushes it right to these nozzles. These nozzles have a pretty small hole in them. They're angled, so it causes it to spin, and I think they're like maybe less than 1/8 diameter, so any rocks or crap that's in that goes right straight to it. And if it's in a pond like this one, under 10 foot of water, you're pretty much...
What kind of flume pipe is it? That sounds like a big blue flume pipe?
It looks like it's a steel cap on the end of some SDR or something, I think, if I remember right.
Okay.
I think it's like a clamp type, kind of like on the bottom of that one that we saw out here. Clamp type transition to go from here to their big SDR.
Okay.
Solenoid valve, again, that's that 1-inch Rainbird valve that's 24-volt AC on the pump station. Make sure that it's operating. If it's not opening or there's a problem with that, you're not going to get water out here to these wands. And in some places, it doesn't take long for this basket to start to build up with debris and restrict the flow going in there. This is the valve that I'm talking about. Out there. There's also a flow control handle. Make sure that that's all the way open. We don't use that. It just needs to be all the way counterclockwise open. There's also a pressure regulator on there. What you do with the standard 1-inch Rainbird valve is you unscrew this coil off of here and you screw on this pressure regulator and then put the coil back on, and now it'll regulate the pressure going out there. The reason we do that is because Clemens, or the CW manufacturer, recommends 45 to 55 psi through the spray wands, just to keep them from wearing out. The higher the pressure, the faster they're going to spin, and it's going to unnecessarily wear them out.
And that would be the reason why you open that valve all the way up.
Yeah, you want full flow, but you want it regulated to pressure.
You allow that to regulate, not your dial.
Yeah, we allow this to regulate it instead of the flow control. This is just a sleeve. You pull it off, you'll see a little yellow indicator with the scale, and it should be set right on 55 is what we set it on.
Does the depth of the screen factor into how much pressure you use to clean it?
No, usually in most applications there's only a couple feet elevation difference. It's not going to add very much to it. It might be 8 feet below the pump station down in a pond or something. 10
Not
feet.
enough to create too much.
Not
impact.
enough to affect it,
I think if you guys put a pressure gauge in the discharge side of that valve, That's a hell of a nice troubleshooting tool.
Yeah, it would be, that would be.
If it just went out of the factory standard with one of those on there, then you know for sure if it's running or not and what pressure it's running. Because personally, those pressure regulating dials, I hate them.
There's a Schrader valve right there. You can unscrew the cap and stick a gauge right there. Right below where the wiring is.
Yeah.
Schrader valve,
Yep. But there was just always one
Always
in the
there all
pipe.
the time, yeah.
Just always one in the pipe.
And where is that gonna give you a pressure reading anyway, with that Schrader valve right there?
Underneath
The
the cylinder.
downstream pressure of the valve.
Cause it's on top of the diaphragm.
Yeah, I'm not sure what the pressure right there would be.
Yeah.
Well, you use a tire gauge.
Yeah.
Oh, that's actually meant to see what it's actually set for.
The downstream gives you your actual downstream
I
pressure.
did not know that.
Yeah.
So you could unthread that and put a pressure gauge on there and it would give you the downstream pressure, right?
Maybe. Never taken out the Schrader valve before and done that, but
But yeah,
It's not
if you had a T, even a T right here.
just have a
something
T
like that.
right there with a pressure gauge on it. Get rid of the pressure regulating dial and just use the flow control on the valve at work. Because the pump station's always doing the same pressure anyway. Pump
Yeah.
station's doing 100 pounds. So there's not a lot of variance in there when the pumps are running. So really all you really need is just the flow control. That's all you gotta do is just adjust that to make your
Adjust that
downstream
to
pressure.
get the right pressure
Yep.
down
Agreed.
there, you
Yeah.
could, yeah.
Well,
Yeah, but if you adjust those down too much, it messes with differential pressure on the irrigation valve and it won't open.
Manufacturers recommend you don't use the flow control to control flow on those.
Flow on
It works great, I'm just saying.
But by having that pressure gauge on the other side on there, that adds another
Well, the
20,
only,
30 bucks.
the only reason they recommend that, so you'll buy their pressure regulator.
It's an $80 pressure regulator. Take that off and put a pressure gauge on.
Gauge on it.
just put a gauge valve
that
there,
doesn't really
you're
work.
done with it.
Yeah, there you go.
The regulator costs more than the valve does.
Yeah.
Yeah.
So we check the pressure regulator, make sure you're getting 24 volts out to the solenoid. You can test it on that field terminal strip that I was talking about. Check it there, make sure you're getting 24 AC out. Usually you feel those are kind of warm, or they make a special tool that you can put up to them too that'll spin. But check, make sure that